Hello, I'm solving this P1 paper today, 9709 variant 12, March 5, 2022. So all answers to 3SF, okay? And angles to 1 dp, unless a different level of accuracy is mentioned in the question. The curve with equation fx is such that f prime x is equal to this, and f8 is equal to 5. That's what we know. Okay, so since f prime x is equal to 2x to the power minus 1 by 3 minus x to the power 1 by 3, what will fx be? We need to integrate this, right? So 2x to the power minus 1 by 3 plus 1 is 2 by 3. This is probably 5 by 3, right? 1 by 3 plus 1, 4 by 3, sorry, plus c. Okay, so fx is equal to 3x to the power 2 by 3 minus 3 by 4x to the power 4 by 3 plus c. So we know that f8 is equal to 5, right? f8 is equal to 5. So 5 is equal to 3, 8 to the power 2 by 3 minus 3 by 4, 8 to the power 4 by 3 plus c. Five is equal to 12 minus 12 plus c. So c is equal to 5, right? So fx is equal to 3x to the power 2 by 3 minus 3 by 4x to the power 4 by 3 plus 5. That's our answer. Okay. Let's move on to the next one. A curve has equation this, and a straight line equation has this equation. Find the set of values for which they intersect at two distinct points. So I'll teach you three things. Imaginary points, right? That means b squared minus 4ac, the discriminant is less than 0. If they say two distinct points, it means that b squared minus 4ac is greater than 0. Okay, this is imaginary, distinct. If they say equal roots, that means b squared minus 4ac equals to 0. And if they say just real, okay, so b squared minus 4ac is greater than or equal to 0. Okay, so right now we write the equations first. Y is equal to x squared plus 2cx plus 4, and y is equal to 4x plus c. Now we equate them. So x squared plus 2cx plus 4 is equal to 4x plus c. X squared plus 2cx minus 4x plus 4 minus c is equal to 0. X squared plus x 2c minus 4 plus 4 minus c is equal to 0. So since the roots are distinct, we are going to use b squared minus 4ac is greater than 0. Okay. Now 2c minus 4 whole square minus 4 into 1 into 4 minus c is greater than 0. That's 4c squared minus 16c, right? Plus 16 minus 16 plus 4c is greater than 0. We can get rid of this. 4c squared minus 12c is greater than 0. C, or 4c, I mean, c minus 3 is greater than 0. So these are the critical values of c. Critical values of c are c is equal to 0 and plus 3. So hear me out. Basically, how do we solve this? We know that this is a curve. This is a minimum curve, right? So this is what the graph looks like. It intersects at 0 and 3. It's a minimum curve. We want the value to be greater than 0. So that's to the left of 3, to the right of 3, and to the left of 0, right? So the final answer is going to be c is greater than 3 and c is less than 0. This is it, okay? Answer. You need to find the set of values. Always look at the question. Like, look for what they want, okay? Now let's do this. Find the term independent of x in the following expansions. There are a few ways you can do this. One way is by expanding this. Okay, one way is by expanding this. I'll show you both ways. So we want it to be independent of x, right? So the first one is 3x to the power 6 plus 6c1 3x to the power 5 2 by x square plus 6c2 3x to the power 4 2 by x square whole square plus 6c3 3x cube plus 2 by x square whole cube. So just think about in which one does it get cancelled out. We're talking about this one over here, right? So this is the term we're looking for. So the term is actually 6c2 3x to the power 4 2 by x square whole square. We end up with 6c2, right? 6c2 15 into 81 x to the power 4 into 2 square is 4 by x to the power 4. So we get rid of this, and the answer is 15 into 81 into 4, which is 4860. So what's the other way though? Basically, you could find it out manually, right? You could find out manually using the formula. It's your wish what you want to do. What's the general formula, by the way, to find this out? Here it's basically gonna be 6c 6cr, right? 6cr thrice x to the power 6cr into thrice x to the power n minus r and 2 by x squared to the power r. That's the formula. So what do we want basically? We want x to the power n minus r, right? We want x to the power n minus r, and this one 1 by x squared to the power r. We want this to add up to 0 ultimately, right? So it's basically trial and error. You can try using trial and error, but I personally prefer expanding it. Okay, so it's NCR a to the power n minus r into b to the power r. So n being, by the way, so if this is n, right? N being 6 here. So it's actually x to the power 6 minus r into 1 by x squared to the power r, right? Or what is this? X to the power 6 minus r into x to the power minus 2r. So we actually want 6 minus r minus 2r to be equal to 0, or 6 minus 3r is equal to 0, r is equal to 2 basically. Okay, so if you input 2 here, you're gonna get this answer. Okay, now the next one, in part B they also want the term independent of x. That means x has to has x needs a power of 0 basically. So when will that occur? Just think about it. When will that occur? Mainly, this expansion is 3x to the power 6, right? Plus 6c1, 3x to the power 5 into 2 by x square, plus 6c2, 2 by x square, 3x to the power 4 into 2 by x square whole square, right? Plus 6c3, 3x cube into 2 by x square whole cube plus dot 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 into 1 minus x cube. So if we want the term independent of x over here, there are two options, right? We can multiply this one with the term independent of x. Remember, that's 62 term. And what's the other way? We also have an x cube over here, right? What if we multiply that x cube with something which results in, getting x to the power 0? So what are we looking for? We want to multiply x cube with something that leads to x to the power 0. We're actually looking for 1 by x cube. Okay, we're looking for 1 by x cube. And where can we find that? The first ones are positive, right? 1 by x cube is probably this term, 63, into 3x cube, right? Divided by x to the power 6. So we are basically going to multiply this term and 1, and this term and x cube, okay? So to find out the term, what are we going to do? It's basically going to be 4860 into 1, right? Plus 63, 3 cube, 2 cube, right? Divided by x cube, right? Into minus x cube. So it's 4860 minus 63 into 3 cube into 2 cube, which is 4320. 480 minus 4320 is 540. That's our final answer, okay? Okay, so we had a progression. The first term of a geometric progression, the first term of an arithmetic progression are both equal to a. Okay, both of them are a. The third term of the geometric progression is equal to the second term of the arithmetic progression. So, like for the geometric progression, it's going to be ar, ar square, and so on. So this is the first term, second term, third term. So ar square is actually equal to the second term of the arithmetic progression. So it's actually a plus n minus 1d, right? So it's just a plus d. The second term is a plus d. So this is one equation. What's the other one? The fifth term, ar cube, ar to the power 4. This is the fifth term. Ar to the power 4 is actually equal to the sixth term of the arithmetic progression. So a plus n minus 1, 6 minus 1, which is 5d. These are our two equations. Now you have multiple roots. You can solve this in many ways. You can either choose to get rid of r. That's a more time-consuming route. There's another faster way. Okay, so the best way to do this is one form of manipulation, right? If you multiply both sides by a, what do you end up with? A square r to the power 4, right, is equal to a into a plus 5d, right? Now think about this side. What about this side? If you manipulate the one on the left hand side, if you square both sides, what do you end up with? A square r to the power 4 is equal to a plus d whole square. So aren't we getting an interesting equation? We can write this as a plus d whole square is equal to a into a plus 5d. That's what they did in the mark scheme, okay? So a square plus 2ad plus d square is equal to a square plus 5ad, or we end up with 3ad minus d square is equal to 0, okay? So if you take d common, 3a minus d is equal to 0. D is equal to 0 and d is equal to thrice a. So d can't be 0, right? The common difference can't be 0, then the sequence wouldn't exist. So we're going to use d is equal to 3a. Now what about the sum of the first 20 numbers of the arithmetic progression, I guess, right? So the formula is n by 2 into 2a plus n minus 1 d, right? So S20 is going to be equal to 20 by 2 into twice a plus 20 minus 1 d, right? So S20 is equal to 10 2a plus 19d. S20 equals to 10 2a plus 19d, right? Or 19 into 3a. 19 into 3a. 19 into 3 plus 2 into 10. I'm getting an answer of 590. 590a, okay? So this is one route. What's the other one? There was a more complicated process. I'm going to show you that one as well. This is way number 2. You have ar square is equal to a plus d. You also have ar to the power 4 is equal to a plus 5d. Okay, basically, right, so there was another way, like the one we did on the left hand side. You could just make r square the subject. R square is equal to a plus d by a. So r to the power 4 is equal to a plus d whole square by a square, right? You could substitute that inside here. A into a plus d whole square divided by a square is equal to a plus 5d. That also works, guys. So a plus d whole square is equal to a into a plus 5d. We'd get the same thing. So you didn't have to think of it that way. So there was substituting, like getting rid of r, right? Now we want to get rid of a or d. Any one works. So for that to happen, the other way, we need to bring a on one side, right? So a ar square minus a is equal to d, and ar to the power 4 minus a is equal to 5d. Or a r square minus 1 is equal to d, and a r to the power 4 minus 1, right, is equal to 5d. So we can actually divide these two equations, right? This can be equation 2, this can be equation 1. So what do we end up with? A r to the power 4 minus 1 is equal to 5d. A r square minus 1 is equal to d. So we're getting rid of d as well as a. So r to the power 4 minus 1 is equal to 5r square minus 5. R to the power 4 minus 5r square plus 4 is equal to 0. We can actually solve this equation, right? 1 minus 5, 4. Okay. So we're getting 1 as r square is equal to 4, and the other one r square is equal to 1. So this can't be the answer, because if r is plus or minus 1, right, the sequence won't exist. It will be the same value, just positive and negative over and over again. So it has to be plus minus 2. R is equal to plus minus 2, but we're going to pick 1. They're giving us a hint. Uh, Basically, they're saying that all the terms are positive, okay? So basically, it can't be minus, because if it's minus, it's going to alternate. So it has to be positive, right? So r is equal to plus 2. R cannot be equal to minus 2. After you get r is equal to plus 2, just input it in any one of the equations, right? Like ar square is equal to a plus d. If you put this in, right, like 4a is equal to a plus d, we're going to get d is equal to 3a, right? This is an example. Now you can just repeat the process we did to get the sum, okay? Now for number 5, express this in this form, right? So we need to take 2 common initially. X squared minus 4x plus 7, then 2 x whole square minus twice x into 2 plus 2 square plus 7, plus 2 square minus 2 square plus 7. So this becomes x minus 2 whole square, and that becomes minus 4 plus 7, right, which is plus 3. This is it. Functions f and g are defined by this. So the interesting part is gx, right? Gx is this one, the one we just completed squares for. So describe fully a sequence of transformations that maps this onto that graph. So what's the change that we brought to x squared, right? Basically, there's clearly a translation of 2 and minus 3. Okay, so translation of 2, 3, right? Why? Because anything that's inside with x, that's a translation the x-axis, and if it's a minus sign, the translation vector will be a positive one. And for y, anything that's outside, anything that's added to fx, right? So this is what we did initially. This is fx, right? X square. We did this first. X minus 2 whole square plus 3. So this part is the x translation, this part is the y translation. We don't need to invert the y one. The y remains as plus 3, okay? So this is the first part. What about the other one? What did we do next? Then we multiplied the whole thing by 2, right? That's the weird part. So since we multiplied everything by 2, it has to be a stretch with stretch factor 2 in the y direction, okay? Followed by stretch in y direction of stretch factor 2. The order doesn't really matter. It does in a sense, I'll tell you. Like here, if we do it this way, if you apply the translation first, then the stretch, then it's fine. Then it's gonna be like this. However, if you apply the stretch first, it's gonna differ in a sense. I'll tell you why. Because see this, what if you had this initially and you go with the stretch factor 2 first? What if you said stretch factor 2 in y direction, okay? In y direction. So this becomes fx is equal to twice x square, okay? Now, here's the thing. If you want this same thing, right? If you want this whole thing, the translation vector needs to be different. Okay, the translation vector needs to be different. Why? See this, if you apply a translation vector of 2, 3, this is what's gonna happen. 2x minus 2 whole square, right? Plus 3. Now hear me out. This isn't the same as the one we had on top, right? Because if we apply the translation first, 2 is multiplied with everything. But hear me out, if you break this down, right? 2x minus 2 whole square, what's the value? 6. So if you multiply the stretch factor first, okay, you actually need to give a translation of 2, 6. That's the important part, okay? So if you choose to say the stretch factor of 2 in the y direction first, you need to give a translation vector of 2, 6, or else it won't match. Because if you give 6, you can take 2 common, x minus 2 whole square plus 3. Now it makes sense, okay? So it's either translation vector of 2, 3 followed by stretch in y direction of stretch factor 2, or stretch factor 2 in y direction followed by stretch in y direction with stretch factor 2 followed by a translation vector of 2, 6. Really important, okay? So just check all the time. So we need to calculate the coordinates of a and b. They intersect at points a and b, okay? So this is the graph x plus 1 whole square plus y minus 2 whole square is equal to 85. And the equation is y is equal to 3x minus 20. Our goal is to substitute this inside. Let's do that. X plus 1 whole square plus thrice x minus 20 minus 2 whole square is equal to 85. So x square plus 2x plus 1 plus 3x minus 22, right? 3x minus 22 whole square is equal to 85. So x square plus 2x plus 1 plus 9x square minus 3 into 2 into 22. 132x plus 20 whole square is 484 is equal to 85. So 10x square minus 130x. This is a 1 by the way. So 1 plus 484. 45 is equal to 85, or 10x square minus 130x plus 400 is equal to 0. X square minus 13x plus 40 is equal to 0. So how are we going to solve this? Pretty simple. X square minus 8x minus 5x plus 40 equals to 0. X minus 8 minus 5 x minus 8 equals to 0. X minus 5 x minus 8 equals to 0. X is equal to 5 and 8, right? So we need two coordinates, right? So clearly b is going to be 5 and a is going to be 8, right? Y is equal to 3x minus 20. So y is equal to 15 minus 20, which is minus 5. This is when x is equal to 5, right? And y is equal to, when it's 8, 8 3 is 24 minus 20, that's 4. So a is actually 4, 4, 8. I mean, a is 8, 4, and b is 5, comma, minus 5. Okay, these are the coordinates. See if you understand. Find equation of the circle which has center at C and for which the line with the equation is a tangent to the circle. Okay, so we have center at C, but it's going to be a smaller circle, right? It's going to be something like this. That line is a tangent actually, right? Okay, so how are we going to do this? So the goal is we need to find, we have the same center, right? Using this equation we can find out the center of C. What's it going to be? Minus 1 2. The center is at minus 1 2. This is what we needed to find out initially. Okay, this is the coordinate of the center, minus 1 2. Now think about it, since it's the tangent, since it's the tangent, it's going to intersect at one point only. It's going to be like this, right? It's going to be like this over here. So we can actually find out, we know the gradient of line AB. Actually, we know the gradient of line AB, right? It's plus 3. Y is equal to 3x minus 3. The gradient is plus 3. So what is the significance of points A and B here, if you think about it? Since AB is a tangent, our circle is going to intersect at the midpoint of AB. Okay, our circle is going to intersect at the midpoint of AB. You need to understand this. Okay, our circle is going to intersect at the midpoint of AB. There are multiple ways you can do this though. Like, you can't use A or B, right? Because they don't fall on the circle. So it's probably a point between A and B, right? It's a point between A and B. And since AB is the tangent, it's the midpoint. So midpoint of AB is actually equal to, what was it? 8 plus 5, right? 8 plus 5 by 2 and 4 minus 5 by 2. So that's 6.5 and minus 0.5. Okay, so now we can just find out the radius, right? The length of the radius. So r is actually equal to 6.5 plus 1 whole square plus minus 0.50 minus 2 whole square. So r is equal to root over 62.5. So what about the center of the circle? It's going to be x plus 1 whole square plus y minus 2 whole square is equal to r square, right? Or 62.5. This is it. You could also keep it as a fraction, 125 by 2. That also works. That's totally fine, okay? So that's it. So why was this actually possible though? Why is it exactly the center, right? I mean the midpoint. Why does it intersect this point? Basically, this is the perpendicular bisector, right? Like if you draw the radius from this point to this point, it's the perpendicular bisector of AB. That's basically why, clearly. So we had to use the midpoint for the circle. Okay, moving on. Show that this is equal to this. It's an identity. Sine theta plus 2 cos theta divided by cos theta minus 2 sine theta minus sine theta minus 2 cos theta divided by cos theta plus 2 sine theta. Let's do this. Right, so for this one, we have to do LCM. So below it's actually cos theta minus 2 sine theta into cos theta plus 2 sine theta. Above it's sine theta plus 2 cos theta into cos theta plus 2 sine theta minus sine theta minus 2 cos theta into cos theta minus 2 sine theta. This is what we have ultimately. Now let's break things down. So sine theta cos theta plus 2 sine square theta plus 2 cos square theta plus 4 sine theta cos theta minus sine theta cos theta minus 2 sine square theta minus 2 cos square theta plus 4 sine theta cos theta. Okay, that's our numerator. And below it's basically a square minus b square, right? Because a minus b, a plus b, a minus b. So it's going to be cos square theta minus 4 sine square theta, a square minus b square. Okay, now let's simplify the one above. Sine theta cos theta plus 2 sine square theta plus 2 cos square theta plus 4 sine theta cos theta minus sine theta cos theta plus 2 sine square theta plus 2 cos square theta, right? Minus 4 sine theta cos theta. Okay, below it's going to be cos square theta minus 4, 1 minus cos square theta. We want it in terms of cos square theta, right? So these are gone. This is also gone. We end up with 4 sine square theta plus 4 cos square theta. Cos square theta minus 4 plus cos square theta. 4 sine square theta plus cos square theta, which is 1, divided by, sorry, below it was cos square theta minus 4 plus 4 cos square theta. So it's 5 cos square theta minus 4, or 4 divided by 5 cos square theta minus 4. That's it. That's all. What about now? Hence solve this equation equals to 5. Okay, so we can, it's a hence question. We're just going to substitute this. 4 divided by 5 cos square theta minus 4 is equal to 5. 4 is equal to 25 cos square theta minus 20, or 25 cos square theta is equal to 24. Cos square theta is equal to 24 by 25. Okay, so we're getting cos theta equals to plus 2 root 6 by 5 and cos theta is equal to minus 2 root 6 by 5. Okay, so check your domain. It's in degrees, right? So 2 root 6 by 5, that's alpha is equal to 11.5 degrees and minus 11.5 degrees. What about this? Alpha is equal to 168.5 degrees and minus 168.5 degrees. So what are the values that fall in our range? theta is equal to 11.5 degrees and 168.5 degrees. These are our answers. Okay, let's move on. How many are there in this question paper? 11 sums. Okay, so we have 8, 9, 10, 11. Okay. The diagram shows the circle with equation this. The chord AB intersects the positive. Find the coordinates of A and B. Okay, so we know that at A, the x coordinate is 0. So if we just input 0, x equals to 0, this becomes 0 minus 2 whole square plus y square is equal to 8, or 4 plus y square is equal to 8, y square is equal to 4, y is equal to plus minus 2. So A is obviously going to be plus 2, right? So it's 2 comma 0. I mean 0 comma 2 because x is 0. These are the coordinates of A. What about B though? For B, basically this is a chord. This is a chord and it says that this is parallel to the x-axis. So this is a line with equation y is equal to 2, right? This is y is equal to 2. Now we want this line to intersect our circle. So if we input y is equal to 2 in the equation, x square minus 4x plus 4 is equal to 8, or x square minus 4x plus 8 is equal to 8, x minus 4 is equal to 0. We are getting x is equal to 0 and x is equal to 4. So the other point is 4. So the coordinates are gonna be 4 comma 2. This is B, 4 2. Next, find the volume of revolution with the shaded area bound by the circle and the chord is rotated. Okay, so we need to do this manually actually. We know the limits, right? It's 0 and the x coordinate was 4. So first we're gonna find this area, this whole thing, the volume actually. We know that volume, it's about the x-axis, right? So we need to make y the subject first. So x minus 2 whole square, x minus 2 whole square plus y square is equal to 8. Let's make y the subject. Y square is equal to 8 minus x minus 2 whole square. Y is equal to root over 8 minus x minus 2 whole square. This is it for now. So the formula for volume is pi integral limits 40 y squared dx. So we have y, right? If you want to find out volume, you need to square this. What does it become? It actually becomes 8 minus x minus 2 whole squared dx, right? Pretty simple. Let's find out the volume now. 8x minus x minus 2 to the power 3 divided by 3 limits 40. So it's actually 32 minus 4 minus 2 whole cube by 3 minus 0 plus 0 minus 2 whole cube by 3. So it's 32 minus 2 cube by 3 minus 0 plus minus 2 cube by 3. 2 cube by 3 is 8 by 3. So 32 minus 8 by 3 minus 0. So we know that a negative number, if you cube that, right, it's going to be another negative number. So this is also minus 8 by 3. So we're getting 32 minus 16 by 3. Obviously there's a pi outside. I forgot to mention that. Pi. So 32 minus answer, that's 80 by 3 pi. 80 by 3 pi. Okay. So that's it for the pink volume. But we need a shaded region, right? So I'm gonna actually subtract this area. This, like, if you rotate this thing, right, about the x-axis, it's gonna turn into a cylinder basically, right? You could do it manually. You could also do it using this equation. We know that that's the equation for y is equal to 2 and volume is equal to integral pi y squared dx. So if you do this, pi 40 2 square dx, it's going to end up as v is equal to pi. 2 square is 4, right? So 4x 40. So that's pi 16 minus 0. So that's 16 pi. So the other way is thinking of it as a cylinder. We know that the volume of a cylinder is pi r square h, right? So what's the height actually of the cylinder? It's actually 4. And what's the radius of the cylinder? It's actually 2, right? So the volume is pi 2 square into 4, which is also 16 pi. It works both ways, okay? So to find out the end result, we want to find out the volume of shaded region. Volume of the shaded region, that's going to be 80 by 3 pi minus 16 pi. Let's do it. So 80 by 3 minus 16, we're getting 32 by 3 pi. They aren't accepting mixed fractions from this year, so you need to, I mean, they aren't accepting improper fractions. You need to convert it to a mixed fraction, 10 whole 2 by 3 pi, or you could answer in decimals as, you know, did they want this in an exact form? They didn't. This is the best way to answer it, okay? Or you could just go for, 33.5. That works as well. 3SF if we're rational. Now we have 9. For 9, solve the equation fx equals to 0. So fx is equal to x minus 4 to the power half x. I mean 4x to the power half plus 1. So let's equate this to 0. So let x to the power half be a, right? So a square minus 4a plus 1 is equal to 0. You could do it this way. If you solve this, what are you getting? A is equal to, okay, so we need to show the general formula or it won't work, okay? You won't get a mark. So A is actually equal to minus b plus minus root over b square minus 4ac divided by 2a, or plus 4 plus minus root over minus 4 square minus 4 1 1 divided by 2 into 1. So what are we getting? Plus 4 plus minus root over 16 minus 4, which is 12 by 2. So root 12. Root 12 is actually 2 root 3. So it's plus 4 plus minus 2 root 3 by 2, or one of them is 2 plus, 2 plus root 3. The other one is 2 minus root 3. Now they don't want x to the power half. They want x, right? We just got x to the power half. If you want to find out x, what do we need to do? We need to square both sides, right? So what are we ending up with? 2 plus root 3 whole square, which is 4 plus 4 root 3 plus 3, which is 7 plus 4 root 3. What about this? X equals to 2 minus root 3 whole square, which is 4 minus 4 root 3 plus 3. That's 7 minus 4 root 3. These are your two answers, okay? Remember that. Given that fx is the same as ghx, find the values of m and n. Okay, so let's find out ghx first, this composite function. H has been inserted into g. Gx was mx squared plus n. Mx squared plus n. Hx is x to the power half minus 2. So we are inserting h into g. So m x to the power half minus 2 whole square plus n, which is m x minus 2 to the 4, 4x to the power half plus 4 plus n, okay? So this is actually equal to fx, and fx was x minus 4 x to the power half plus 1. So let's equate these. Now we can equate the coefficients. X minus 4x to the power half plus 1 is the same as mx minus m 4x to the power half plus 4m plus n, right? So if you equate the coefficient of x, m is actually equal to 1 because there's an imaginary 1 here, right? And 4m plus n, equating the constants, is equal to 1. So 4 plus n is equal to 1 and n is equal to minus 3. That's your answer, okay? Hopefully that makes sense. We're almost at the end. We're doing number 10 now. Find the perimeter of the shaded region. It has a few sections, right? The radius of the smaller circle is 5 and the radius of this circle is 8. So we can find out dB first. dB square is equal to dA square minus, sorry, BA square minus DA square. So basically 13 square minus 5 square. That seems familiar. That's 12. dB is actually 12. Okay. So think about it. BE is 8. So what's the value of DE gonna be? DE is equal to 12 minus 8, which is 4. You get 1 mark for this. We found out DE. Now we need these two arc lengths, okay? Orange and purple. EC. EC and DC. Okay, let's go for it. So for that we need the angle, right? Let's find it out using trigonometry. Like dBA. We can just use tan or sine, you know. Sine dBA. You should set your calculator radians, by the way. Sine dB is equal to opposite 5 by hypotenuse 13. dBA is actually equal to 0.39479. Okay. So the arc EC, we know that it's equals to r theta. So EC is equal to r, which is 8. 8 into 0.39479. We're getting a value of 3.15832. Okay, what about the last section, the orange one? We want to find DC now. So that angle is just gonna be, okay, you can find it manually. You can find manually. Using cos, maybe. Cos DAB is equal to adjacent by hypotenuse 13. So DAB is actually equal to 1.176005. I'm just storing these in my calculator. Now EC is equals to r theta, right? I mean DC. So DC is equal to r theta, 1.176 into 5. We're getting 5.880026. Now about the perimeter, it's gonna be DC plus EC plus DE, right? Or 5.880026 plus 3.15832 plus 4. We're getting a value of 13.04, but we need to answer to 3SF always. Okay, always 3SF if irrational. 13.0 centimeter. That's your answer, okay? Be careful. Now find the area of the shaded region. This is a bit simpler. Let's find out the area. Okay, so we just want to find out the area of the triangle and subtract the area of the sectors. That's basically it. So area of shaded region equals to area of triangle, right? Minus area of sectors. So the area of the triangle is half into base into height. The base is 5 and the height is 8. 8 plus 4, 12, right? 5 plus 12. 5 into 12. This is the area of the triangle minus area of the sectors. We know that the area for sector, the formula is half r square theta. So half for the smaller triangle is going to be into 5 square into 5.880226. Sorry, into 1.176005. This is the smaller triangle. I mean the sector. Now the bigger sector, half into 8 square into, what's theta? 0.39479. 0.39479. Or you could use your saved values. That's fine. Okay. Half into 5 into 12 minus 0.5 into 25 into 1.176005 minus 0.5 into 8 into 8 into 0.39479. Okay. You're going to get a value of 2.66665 or something. It's rounded off to 2.67 centimeters square. That's your final answer. Okay, they accepted values ranging from 2.66 to 2.67. That's accepted. Okay, now we're off to the last sum, the final sum in this paper. It's given that the curve has equation this. Find in terms of k the values of k at which there is a stationary value. Okay, so we just need to equate, we need to find out dy by dx basically. So that's going to be k, 3k minus k to the power minus 2, right? Or let's do it this way. K into the minus 1 is going to come down. 3x minus k to the power minus 2 into 3. So we end up with plus 3, of course. We need to differentiate this. So minus 3k divided by 3k minus k whole square plus 3. This is it. Now we want to find out where the stationary point is. Dy by dx equals to 0. So minus 3k divided by 3x minus k whole square plus 3 is equal to 0. Or 3k divided by 3x minus k whole square is equal to 3. Now we cut these off. K is equal to 3k minus k whole square. This is what we got. Now we just need some simplification. Okay, so 3x minus k is equal to plus minus root k. We want to make x the subject. 3x is equal to k plus minus root k. So x is equal to k plus minus root k divided by 3. That's it. This is our answer. Okay, makes sense. Now find the value of a and determine the nature of the stationary value. Interesting. So we can apply an easy trick. You can do this manually. That's going to take some time. I'm going to show you an easy trick. Check this out. So look at this. It's 4 over here, right? So what value is k taking? K is actually taking the value 4. You need to identify that. K is equal to 4 here, right? And we know that the stationary point is actually, you know, x is equal to k plus minus root k by 3. Okay. So for one of them, x is actually equal to 4 plus root 4 by 3. The other one is x equals to 4 minus root 4 by 3. So one is 4 plus 2 by 3, which is 2. The other one is 4 minus 2 by 3, which is 2 by 3. But here's the thing, you can't take 2 by 3 because we have a domain of greater than 1.5. This 0.67 can't be the answer. So we're going to take this. We're going to take x is equal to 2. Now we want to determine the nature of the stationary value. Okay. So for that we need to find out dy by dx anyway. Dy by dx was this equation, right? This thing. Let's just do it manually. It's fine. So dy by dx is actually equal to 4 into minus 1, 3x minus 4 into 3 plus 3, right? So that's wait, it's fine, right? Yeah. So it's minus 12 divided by 3x minus 4 plus 3. You could equate this to 0, okay? That would be fine as well. Now let's find out d square y by dx square. What's going to happen? Basically, this can be written as minus 12 3x minus 4 to the power minus 2 plus 3. If we differentiate this further, minus 12 into minus 2, 3x minus 4 to the power minus 3 into 3. So we end up with 12 into 2 into 3, which is 72, plus 72, 3x minus 4 to the power minus 3, or 72 divided by 3x minus 4 whole cube here. Now we know that x equals to 2, right? So if you input this here, we get 72 divided by 3 into 2 minus 4 cube. So 72 divided by 8 is 9. So since this is a positive value, we're going to say that it's a minimum point. That's the nature, okay? Now we have the last question. The function g is defined by gx. This is also the same one as this. What's the value of k though? As you can see, k takes a value of minus 1 here. K takes a value of minus 1. So what is gx actually? Gx is minus 3x plus 1 to the power minus 1 plus 3x. So we can find out g prime x easily by substituting minus 1 here. What do we get? Plus 3 divided by 3x plus 1 whole square, right? Plus 3 divided by 3x plus 1 whole square. So g prime x is actually equal to plus 3 divided by 3x plus 1 whole square plus 3. So there's 1 mark for getting this. Now you need to state whether this is an increasing or decreasing function. For an increasing function, dy by dx is always greater than 0. For a decreasing one, it is always less than 0. So hear me out. G prime x is always greater than 0. Why is that? Why? Why is g prime x always positive? Because 3x plus 1 whole square is always positive, okay? Hence, gx is an increasing function. That's it basically. Because think about it, there's a whole square here, right? So even if x takes a negative value, even if it's negative, if you square it, you're gonna get a positive value, right? That's why gx is an increasing function. Okay, that's all. If you have any questions, you can ask me.